Hello class, today we're going to talk about section 6.8, which is systems of inequalities. By the end of today's lesson, you will be able to graph to find the solutions to the system of inequalities. So, a system of inequalities is a set of two or more inequalities with the same variable. Again, similar to what we looked at when we were looking at equations, we can have more than two expressions to work with, but for our purposes, we are just going to be looking at two inequalities with two variables. When we are looking for the solutions, this is going to be the area where the graphs overlap. If you remember back to our previous chapter, when we graphed inequalities, we would have put our graph on the line, either with a solid or dashed line based on our y equals mx plus b format. And then we had to use a test point, 0, 0, mainly, to decide which side of our line was going to be our solution. If 0, 0 worked, we shaded with 0, 0, and if it didn't work, we would have shaded on the other side without 0, 0. So if you recall, when we are graphing inequalities, there is not only a line, but there is a shading element to it. When we are looking for the system of inequalities, we would have our first line, and then I'm just going to put in a second line. And we could have our second shading going on. And our point is to look for the area of overlap. So we're looking for this section of the graph where they overlap. That's going to be our solution area. So your steps here, graph and shade for the first inequality, graph and shade for the second inequality, and then that third step is going to be to somehow highlight or shade darker into the area where the overlap is so that you know what ordered pairs work for both equations. So we're looking for the things that work for both inequalities here. So for our first one, we have y is greater than 5. Remember, when we are looking at just y, I want to come up to that y point. So I'm going to go up 1, 2, 3, 4, 5. Here is a point for y is equal to 5. And there is another point for y is equal to 5. Now, because we have greater than, we are going to have a dashed line because it is just greater than, and it is going to be a straight horizontal line. So there we go, going all the way across, making sure we've got our arrows on the end. Then we want to go in and double check. So we're going to say 0 is greater than 5. That is a false statement, which means 0 is not part of our answer. So we are going to shade above that line. Then we're going to come to our second one, and we've got x is less than or equal to negative 4. So now we're looking at x. So I've got 1, 2, 3, negative 4. So there's my first point where x is equal to negative 4. Here's another point where x is equal to negative 4. So when I connect these, we are going to be looking at a vertical line, and it is going to be solid because we have that equal to part again. So I've got my solid vertical line. Then once again, I'm going to want to test my points. So I've got 0 is less than or equal to negative 4. That is, again, a false statement, so I don't want to include 0 as part of my answer. So we shade on the opposite side of 0. The last thing we have to do, now that we've graphed and shaded inequality 1 and graphed and shaded inequality 2, we have to do step 3, which is to find that overlap area. So that's where the red and the blue intersect. So we've got this area up here. So you either are going to want to shade that in a different color, like I am doing, get it out with a highlighter, or shade it in super darkly with pencil. Whatever works best for you, but make sure it is clear the area of overlap. So you want to make sure that you are clearly highlighting the area of overlap. Go ahead and try this one on your own. When you are done, type done into the response box and check your graph. So that first one, x is less than 4. That is that red dashed line over on the right side, and that is a true statement, so we shade it to the right. Then we have y is greater than or equal to -3. That is that solid horizontal blue line. That is a false statement when we plug in 0. So our overlap area is this green highlighted area down at the bottom. If you have questions about these one variable things, please let me know when you get to class. Then we're going to step it up a little bit, and we have our equations with 2 variables in them. Similar to what we have done before, we need it in y equals mx plus b format. So the first thing I'm going to do is add x to this side. So I've got y is less than or equal to x plus 3. I'm going to advise that you take this one inequality at a time. You could go ahead and start solving the second one, but I would advise you to deal with one inequality at a time so that you don't mess up any shading or anything. So now that I've got my graph, I'm going to come up 3 as a starting point. My slope is 1 over 1, so I'm going to go up 1 and over 1. Since it is a less than or equal to, we're going to want to put in a solid line, and we are going to go ahead and connect our points, and then we are going to want to shade. So I'm going to want to plug in 0, 0. I would advise just doing it into the original equation. So I've got 0 minus 0 is less than or equal to 3. 0 minus 0 gives me 0 is less than or equal to 3. That is a true statement. So I am shading on the side with 0. Notice how I'm not putting too much shading into it, so that it'll be easier to see the overlap. I'm going to go ahead and start the next one by subtracting x from both sides to give me an expression of y is greater than or equal to negative x plus 1. So I'm going to start at a positive 1. My slope this time is negative 1 over 1, so I'm going to go down 1 and over 1. Again, we have this equal to part, so I'm going to go ahead with my line and use a solid line all the way through the graph and hitting both of my points and adding the arrows onto the end. And then we're going to need to shade, so I'm going to plug into the original. 0 plus 0 is greater than or equal to 1. The 0 is greater than or equal to 1 is a false statement, so I do not want to include the side with 0. So I'm going to shade on this side, this right side of the graph. And now we are looking for the overlap, so the place where the red and the blue are touching, and I'm going to make that the darker part for my answer. So you want to make sure that you've highlighted that whole area to make it obvious where the solution is. Go ahead and try this one on your own. So we didn't need to do any rearranging here. This first one is the red line starting at 1, going down 2 and over 1. That gave us a false statement, so we are shading on the right side away from 0. The blue line starting at 3, going up 1 and over 1. That gives us a true statement when we plug in 0, so we are shading on the right side with 0, and that green area is again the overlap. If you have questions about that, please let me know when you get to class. So this last one is going to show us a case that is a little bit different from the other ones that we have done so far. So we are going to start at 7 and go up 1 and right 6. Since it does not have an equal to part, we are going to put in a dashed line connecting both of our points all the way through. So when I plug in 0, I've got 0 is greater than 0 plus 7. That is going to give me 0 is greater than 7, which is a false statement. So I'm going to shade above that line so it doesn't include 0. Then I'm going to come down here and add x to both sides. and I'm going to get 6y is less than x plus 12. Dividing everything by 6, I'm going to get y is less than 1/6 x, since there was a 1 in front of the x originally, and then plus 2. So I'm going to come up to my graph and start at 2 and go up 1 and over 6. Again, there is no equal to part of this, so I am going to go ahead and draw in my dashed line connecting my points. And then I am going to plug in 0 into the original equation. So I've got 0 plus 0 is less than 12. 0 is less than 12 is a true statement, so I want to shade the side with 0. As you can see, there is no overlap to these two inequalities. So when there is no overlap, this is the no solution case. So if there's no overlap between the two graphs, this is no solution. If you have questions about this or anything else from the lesson, please let me know when you get to class.